Welcome to this edition of Train for Aptitude. Today we look at the sixth concept in the problems on streams and boats. Let us begin reading the problem. A man rows to a place 48 kilometers away and comes back in 14 hours. He finds that he can row 4 kilometers with the stream in the same time as 3 kilometers against the stream. The rate of the stream is, our options are A 1 kilometer per hour, B 1.5 kilometers per hour, C 2 kilometers per hour, D 2.5 kilometers per hour. Based on the problem, we can visualize it as shown. What we need to note here is that the time to row 4 kilometers downstream is the same as the time to row 3 kilometers upstream. Note also that the boat is assisted by the flow of water while going downstream, and while going upstream it is hindered by the flow of water. The total journey distance both ways is the same. The assumption, as always, is that the boat and the stream are always moving steadily throughout the journey. To solve the problem, we begin by looking at information given to us. It is mentioned that the distance one way is 48 kilometers. The total time of travel, both downstream and upstream together, is 14 hours. It's also mentioned that the time to travel 4 kilometers downstream and 3 kilometers upstream is equal. We first form equations for the speed downstream and upstream by assuming that the time taken to go 4 kilometers downstream and 3 kilometers upstream to be t. That is, speed downstream is 4 by t and speed upstream is 3 by t. We next look at forming the equation for the time to travel the whole distance and substitute the speed downstream and upstream in this equation. On solving, we find that the time under consideration is t is equal to 1 by 2. Next, we calculate the total time to go downstream and upstream with the other equation, that is, the speed of the boat plus speed of the stream is the speed downstream, that is SW is equal to SB plus SS is equal to 8 kilometers. Similarly, SB minus SS is equal to 6. We next solve for the speed of the stream by subtracting the two equations. When we solve it, we find the speed of the stream is 1 kilometers per hour. To be able to generalize, we assume the speed of the boat is SB, the speed of the stream is SS, the distance one way is denoted by D, the information, that is the time to go downstream plus the time to go upstream, is X. It is also given that the time to travel A kilometers downstream and B kilometers upstream is equal. We next form the equations from the information given for the speed downstream as A by T and speed upstream as B by T. We next begin with the information for the total time, that is the total time to travel downstream plus upstream is X is equal to the distance one way divided by the downstream speed plus the distance one way divided by the upstream speed, that is X is equal to D by A by T plus T by B by T. Then solve for T. Having solved for T, we next substitute the value of T into the equations from step 1 and then also substitute for the speed downstream and speed upstream. We finally solve for the speed of the stream, the two simultaneous equations in step 3, to find that the speed of the stream is equal to half of A by T minus B by T kilometers per hour. Thank you for watching Train for Aptitude. Please encourage us by following our YouTube channel and liking our Facebook page. You could also check us on our website trainforaptitude.in.